Hi girls, this is the second part of that lecture I was telling you about. This is about energy in an ecosystem. So this is what we did yesterday that you guys came in late for. Give me just a second, I'm pulling up this PowerPoint right now. Taking way longer than I thought it would. I'm going to go ahead and sorry, I hate all this dead time. I feel like I'm wasting your time. Okay, here we go. This is what I wanted to share. Okay, so last time we talked about the biosphere, and I gave you the quick overview of that, and today we're going to talk about how energy flows through an ecosystem. So let's start with our objectives for this section. So we have identifying the source of energy for life processes, tracing the flow of energy through these systems, and evaluating how efficient that process is. Here's your vocabulary. Again, this is available to you in the notes that I provided for you. Okay, so let's start with producers. Producers are organisms that produce their own food. The source of energy for them is the sun, of course, because they are able to use the sun to photosynthesize. Autotrophs is another fancy word for producers. The word auto means self and trophic means nourishing. So if you put them together, it means self-nourishing, or they make their own food. Some examples of those are plants, algae, and certain types of bacteria. Photosynthesis, as I just mentioned, is a process that converts light energy, carbon dioxide, and water into oxygen, sugars, and starches. You guys should have learned that last semester. Here's a picture of that just to kind of get a visual. And it's important to note that you see the leaf here. The leaf is where photosynthesis happens. Chemosynthesis is pretty similar, where the photo part of photosynthesis means using light to synthesize or make energy. In chemosynthesis, these organisms use chemicals to make or synthesize energy. So they're able to use all kinds of things, sulfur or other inorganic chemicals. And here's an example. Down here at the bottom, you see that you have these tube worms. Well, these tube worms live at the mouth of underwater volcanic vents, and they take the hydrogen sulfide and oxygen and the carbon dioxide that's dissolved in the ocean's water, and they're able to make carbohydrates that they use for energy and to build their tissues. So even though there's no sunlight, they can still produce energy. Consumers, or heterotrophs, are organisms that rely on other organisms as their source of energy. So think about it like to consume means to take something into your body, right? Well, these have to take other organisms into their body. And hetero, if you remember from other chapters, means other. So you put hetero, other, with nourishment. They need others for nourishment. So that's how you break those words down. Herbivores are, of course, plant eaters. Some examples here are deer and cows. Carnivores eat meat. They eat other animals in particular, and some examples are lions and wolves. Detrivores are animals that, or excuse me, organisms, because they're usually bacteria, that feed on plant remains and animal remains and anything that is already dead and decaying. Some examples are mites, earthworms, snails, and crabs. Decomposers is a synonym for detrivores because they break down organic matter. These tend to be fungi and bacteria. So feeding relationships show the energy flow. It goes one direction from the sun or an inorganic compound to autotrophs, which are, again, the producers, and then to various heterotrophs, or consumers. The consumers eat the producers, and that's how they get their energy. So here is a simple food chain, which is a series of steps in which organisms transfer energy by eating or being eaten. I want you to notice the arrows. Do you see how if you look at the arrows, it looks like it's saying the algae eats the zooplankton eats the fish eat the squid, and the squid eats the shark. Well, that's not really what's happening, is it? What the arrows show are the flow of energy. So it's saying the shark gets its energy from the squid because when it eats it, it gets those calories and is able to have energy to do work in its body. The same is true when the squid eats the fish eat the zooplankton, and the zooplankton eat the algae. The algae are microscopic plants, so they get their energy from the sun. A food web is a little more complex than a food chain because it shows all of the possible feeding relationships within an ecosystem. And here is an example of that. As you can see, that heron at the top, it eats both the mussel and the small fish. So if one of those organisms were to die out, then it could rely on the other ones. But what would happen to that population of small fish if the mussel were to die? Probably that population of small fish would decrease greatly because the heron's not only eating, is not eating the mussels and the fish, it's only eating the fish. So it would be predated upon more. Trophic levels, remember that trophic means nourishment. So these are levels of nourishment within an ecosystem, is the step in a food chain or food web. So it always starts with the producer, which gets its energy from the sun. And then you have different levels, which are all consumers that rely on the level before it for energy. How we show this is usually in an ecological pyramid, which is a diagram that shows the relative amount of energies contained within each trophic level in a food chain or food web. Here you can see an example of an energy pyramid. It's and you can see at the bottom you have the producers, which give their energy to the primary consumers, which give their energy to the secondary consumers, which give their energy to the tertiary consumers. Something that is really important that you need to remember about energy levels is, or the trophic levels, is that only 10% of the calories in one level get transferred to the next level. So that means if in this food chain that we saw right here in this pyramid, if those cattails get 10,000 calories from the sun, those grasshoppers are only going to get 10%. So that's 1,000 calories from the cattails. And the grasshoppers, and those birds, those pigeons maybe, when they eat the grasshoppers, they're only going to get 10% of that 1,000 calories. So they're only going to get 100 calories from the grasshoppers. And then that tertiary consumer, the hawk, when he eats the pigeon, he's only going to get 100 calories. No, I'm sorry. I missed one. So it's 10,000, 1,000, 100. He's only going to get 10 calories from that pigeon. Most of the energy that is lost from level to level is lost in heat because it takes a lot of heat energy to break food down. Sometimes you'll see this relationship expressed by a pyramid of numbers, and this shows the relative number of individual organisms at each trophic level. So for example, here's another food pyramid. You can see it looks similar to the other one. We have producers at the bottom, then herbivores, and then omnivores or primary carnivores. And then at the top, we have a top carnivore or a tertiary predator. Well, you can see that to support this one carnivore, we have to have 90,000 primary carnivores or omnivores. And then to support their population, you have to have 200,000 herbivores. And then to support those herbivores, you have to have 1,500,000 producers. That is a lot of organisms that are needed to support this food chain. And then after this lecture, you are supposed to complete that ecological pyramid activity. If you had questions about how to go about completing that, or if you weren't really sure what it was supposed to look like, please email me and I will make you another video with step-by-step instructions of how to do that and examples of what it's supposed to look like. And once again, if you have any questions, please feel free to email me. I am happy to answer any that you have. Have a great day.